Today's a pretty simple little lesson here. Carter or Trevor, will you close that door, please? What Beyond Fair book? Well, the little subheading is renaming by multiplying by 1. Now, in order for you to kind of gather what that is, we have to think about what happens when we multiply by 1. 8 times 1, 12 times 1, 15 times 1, 1/2 times 1. What happens when you multiply by 1, Sam?
You get the same number.
Right. You always get the same number that you started with. That's kind of a rule of thumb. We actually call that the identity property of multiplication. Identity property. Well, now to take that one step farther, let's go away from that for just a minute. In math, if you have the number 1, in fraction form, there are billions and billions and billions of different ways we can write the number 1 in fraction form. For example, if you had a pizza and you told the pizza place to only cut it into 2 pieces, in order to eat the whole pizza, you would eat 2 of them. Or if you told the pizza place to cut it in 3 pieces, you'd eat 3 of them. Or 4 pieces and you'd eat 4, or 5 and you'd eat 5. So all of these fractions, watch this, all of these fractions are the same thing as 1, are they not? 2 over 2 is the same thing as eating 1 whole pizza. 3 over 3 is the same thing as eating 1 whole pizza. 4 over 4 is the same thing as eating 4 pizzas. And 5 over 5 is the same thing as eating a whole pizza, and so on for the rest of your life, right? Ready? Now here's where the deep breath comes, Sam. We are taking this and putting it together and saying this. If I take a fraction, let's say I have the fraction 2/3, and I multiply it by any of these, it's the same thing as multiplying it by 1. Let's take this one, for example. So 2/3 times this fraction that is the same thing as 1. 3/3 is the same thing as 1. And I multiply those together, which, by the way, when you multiply fractions, you just multiply across. You get 6 over 9. Because I multiplied 2/3 by 1, my answer to that is the same fraction. 2/3 and 6/9 are exactly the same. They are equal because of this rule. 2/3 times 1 is still 2/3, but it's in a different form. If you ate 6/9 of a pizza, you ate the same thing as 2/3 of a pizza. And you could do that times any number. I could go times 500 over 500. Anybody do 2 times 500 in their head? 1,000. 3 times 500 in their head? 1,500. These fractions all mean the same thing. It's almost like reverse reducing. I don't want to say it's expanding, because you're not really expanding or making it any bigger. You are just changing it in a different way. And you say, what good is that? Well, we need to be able to do that a little bit later on. For today, you won't understand why, but later on you will. Now, with that being the case, we also are going to see problems that look like this. 3/5 equals what number over 20? Okay. First things first, if you see this problem in the book, you need to write that out. Don't cut any corners. Write out the problem. Then you need to think about what fraction of 1, because these are equal, what fraction am I multiplying 3/5 by that will give me a 20 on the bottom, which means this. You just say, well, 5 times what is 20, Charlie?
4.
4. So if you multiply the bottom by 4, in order for the top to make equal fraction, you have to multiply the top by 4 because 4 over 4 is the same thing as 1. And 3 times 4 is 12. So 3/5 equals 12 over 20, and then you can please just circle that so when you read the answer, I will just read 12. Or what about this one? 3/4 equals how many eighths? 3/4 equals how many eighths? They'll put a question mark there. What number goes on top up there? Again, you'd have to say 4 times what is 8? Ethan, 4 times what is 8? 2, so I have to multiply the same top by 2 as well, and you get 6. Alright, now ready for the final countdown here. Write this problem down. Here is an example right from the book. Write the fractions write the fractions 1/2 and 1/3 with denominators of 6 and add them together. Ready? I'll give you a little time to make sure you get it written down. If you see this problem in your book, Leah Tenton, what you are going to do is this. You're going to take 1/2. You need to have it, make it so that it has a denominator of 6. So how do I do that? Well, the denominator is the bottom number. It's just what we did before. 1/2 is what number with the denominator of 6? Sam? If I multiply by bottom by 3, so the top by 3, I get 3/6. I then need to take 1/3, make it have a denominator of 6, which would be what?
2.
I have to multiply 3 times 2, so the top times 2. And then they said once you've changed them both to denominators of 6, add these two fractions together, which would be 5, 6. Remember, you don't add the bottoms together, just the tops. This would be what I would need to see on your homework for that problem. Is that a difficult task or an easy task? No, yes, no. Make sure you show that to me because you don't want to get the alternative, correct? Alternative is bad, but I think you can probably handle that. I think we did this last year.